Okay, so this is Math 2. We left off on 22. We're going to pick up with 23, which, by the way, is probably the longest, most involved problem I've seen so far. So I'm going to give you 5 seconds to pause if you need to, because you need to go and copy down this picture on your paper. It's a pretty involved problem. And make it pretty big because we're going to be drawing all over it. So first thing, EX is tangent to circle O at point X. So if this line is tangent to this radius, then it should automatically give me a 90-degree angle in this top corner here. Okay, that's 90 degrees. Tangent with this to a circle is always at 90 degrees with the radius. OE is 20, so from O to E, so this whole entire segment here has a distance of 20, right, from here to here. Oopsie, from here to there. And then E to X is 15 centimeters. All right, what's the area of the circle? Well, before you can get into the area of the circle, which by the way is pi r squared, you need to find the radius. So if you look at this, it's not 20, because this 20 definitely goes outside the circle. You really should be finding this part right here. Let's call it R for radius, because that's really what it is. So what is this part of the circle? And if you look at the triangle, since it's a really nice triangle, it gives you a right angle. Your hypotenuse is 20. This is 15. So what is your radius? And this can be easily done, hopefully you see, by doing 15 squared plus r squared is equal to 20 squared. All right. And you should get r equals whatever 400 minus 225 is, and then you should get 13.2. Okay, somewhere around 13.2. So we'll go with 13.2. Okay. Okay. Now, so that's your radius. So your area is going to be pi times radius squared. So when it was r squared up here, 400 minus 225 was 175. So r squared should have been 175. So that means here, when you do your area, r squared should automatically be taken from here. It's just 175 pi, because r squared is just 175. And then, so 175 times pi is going to equal somewhere around, so area of this circle is going to equal 549 point, let's say 0.78. I'm around to do decimal places since we're going to be decimaling everything in this area. Okay, 149.78 is the area of the circle. Since it's in centimeters, centimeters squared. Okay. Okay, next. What is the area of the sector bounded by OX and ON? So what it wants is the area of the sector. The sector meaning the slice of pizza that is over here. This one in orange. Okay. In order for you to actually get that part, you need to figure out what this angle is on the inside here. It's not 15. It's not half of 15 either, because this 15 is not this arc. So you can't tell me 15 or whatever, 7.5 or something like that. That's not true. What you need to do is actually use inverse trig, because what it's essentially asking you is to find theta, or find this missing angle here in this right triangle. So you know this is 20 degrees, this is a right angle, this is going to be our 15. We found r, but we don't really need it right now. You need to find theta, because that angle is what is going to help you find the area of that sector. Theta is going to be equal to inverse, what is this, opposite and hypotenuse? So sine inverse of 15 over 20. So you should get something around 48 point, what, 48 point something. Okay, inverse, well, let me see, 48 point, inverse sine, let's see, inverse sine 15 divided by 20 should be 48.6 degrees. If you didn't get 48.6 degrees, it should look like this on the calculator. So if you did inverse sine of 15 and then divided by 20, that'll probably mess things up. So it should be 48.6 degrees, somewhere around there. Okay, so that's this angle, which means we can actually do the area of the sector. So the way that, who taught me how to do this? Was it Abby or Anna? One of them did this way, and I'll take this way. So 360 over 48.6 is going to be how many slices you can make in here. So 360 divided by 48.6 means I can have 7.41 slices, which I know doesn't make a lot of sense, but just roll with it. So I can make 7.41 number of slices. Well, we already found the area of the circle in the previous part. The area of the circle was 549.78. So if I know the whole area is this much, and each slice is there are 7.41 number of slices, then I can just take the area of the whole thing, divide by how many slices I have, and find the area of each slice. So area of the sector is going to equal 549.78 divided by 7.41. And that should give me 549.78 divided by 7.41 and 74.19. 19 centimeters squared. Area of the sector. If you rounded too much, then your numbers are going to be off by a couple of decimal places. Okay. So 74 is the area of this orange sector over here. Okay, now, what is the area of the region bounded by XE, NE, and the arc NX? Now, if you look at this, you're like, how in the world? But it actually makes perfect sense when you just think about it for a couple of seconds here. You have a triangle, right, in here, and you have this area part right here. If you find the area of the whole triangle and take out the orange part, you should be left over with this random piece that's over here, which now in hindsight should make sense. So if you find the area of the triangle and then take out or subtract out the area of this orange sector, you should have this little funky piece hanging over here. Call it the shark fin. Look, that looks like a shark fin when you think about it. Okay, so area of the triangle is base times height divided by 2. Well, you should not be using 20 because that's not a very nice base to use. If you turn the paper around, your base is really your radius and your height was the 15, which makes it super convenient now. Radius was 13.2, your height was 15. So 13.2 multiplied by 15, all divided by 2 should give you 24. Divided by 2 should give you an area on the triangle of 99 centimeters squared. Okay. Now, area of the sector you should have gotten was equal to 74.19 centimeters squared. So if you take away the sector, so if you subtract out the sector from the area of the triangle, you should get the area of whatever's left over. Okay? And don't forget centimeters squared. That was 23 and it was super long. Okay, 24. Let's try to breeze through this. I actually just did it straight up. So what you're supposed to do is rewrite in graphing form, then use the equation to determine what happens to the x-intercepts algebraically. So you're basically just solving it. This is your perfect square. So you have x squared. Half of 3 is 1.5. So 1.5x, 1.5x. 1.5, 1.5, there's your perfect square. 1.5 times 1.5 should give you, oopsie, I'm zooming in, sorry. I don't know what 1.5 times 1.5 is. I'm assuming 2.25. Yep, I was right. 2.25. Alright. 1.5 times 1.5 is 2.25. It's not 3. You're not adding them together. Okay, so you want 2.25. You have 4, so you're going to need to take something away, as far as I know. So that means you're going to, let me just write this out. So 0 equals x squared plus 3x plus 4. You're going to need to subtract, I don't know, 1.75, right? So 4 minus 1.75 is 2.25. There you go, see? So I'm going to subtract 1.75 from both sides, which gives us, or leaves us with, negative 1.75 on this side. And then in here we have x plus 1.5, x plus 1.5. And that's really just x plus 1.5 squared equals negative 1.75. But that's not graphing form, because graphing form looks like this right over here, where my pencil is at. You need to move or add the 1.75 to the other side, right? This is graphing form because from here you can tell what the vertex is, which, by the way, should be easy to do now, negative 1.5 and then 1.75. Okay, that's your vertex. It's not negative out here because it's not in parentheses. Okay, now that's your graphing form, or vertex form. I don't know, whatever you want to call it. Then use either equation to determine the x-intercepts algebraically. So basically it's just asking you to solve it if possible. So if you take, or if you continue on from this, right, if you want to actually solve this, you would end up having to take the square root of both sides. But when you try to do that, you should automatically see that a negative underneath the radical sign is going to give you a domain error, which means you're going to end up with i's. So realistically, if you get i's when you're trying to solve it, it's not going to ever hit the x-axis because there's no solution that you're going to get. So with the vertex being at negative 1.5 and 1.75, plus it's going up because it's not negative in front of the x squared, it's probably going to look something like that, where it's not going to hit the x-axis at all. It's just going to be an open parabola with the vertex right over there at negative 1.5 and positive 1.75, right over there somewhere. Okay, that was 24. 25, calculate the perimeter of each shape below. You need to find the missing side. So on part A, I guess you can call this x and you can call that y. You're going to have to use some trig. Maybe. It's probably faster if you don't use trig, but if you don't know the shortcut, then just forget about it. You're going to need to use trig to find x and y 2 times. So one for the x and then do another one for the y. The perimeter is just add up all the outsides, not the area. We don't know the area. So sine or cosine, whichever you prefer. Part B. What are we doing here? This is a parallelogram, isn't it? It's just a parallelogram. The area of a parallelogram is base times the height. Oh, you want the perimeter. My bad. I thought it was the area. I was like, why is this so difficult? Okay, this looks complicated. How are we going to break this apart? Let's see. That part's 9. Oh, well, this part's 9. I know that. Because it has to be. Oh, it's 18 from here to here. Okay, that makes more sense now. So the whole thing is 30. That's 18. So that means this part is 30 minus 18. Stop it. 30 minus 18. I have issues. Okay, so that's 12. And then find x, right? It's just the right triangle in this part, so that should be good to go. This part is 18. That's 9. That's x. Assume the diagram in part B is a parallelogram. Oh, so that means the opposite sides are congruent. Okay, so if you find x on this side, your parallelogram is going to have the opposite sides are the same. So if this is x, this part's going to be x too. So that means once you find x using Pythagorean theorem, you should just, put the same thing over here. So that's going to be 18 plus 18. This is going to be 18 too. 18 plus 18 plus x should give you the perimeter of the whole thing. All right, and then part C is, oh boy, okay, so I'm going to drop an angle down. That's 6, so this is 6. But how is that going to help me? That's not going to help me. That actually doesn't help you at all. This is 11, that's 7, so this must be 4 from here to here. Oh, okay, then you can just use trig to find the entire part right here. So 60 degrees, you have an opposite, so I guess you can call it x, and you have an adjacent. Find x. Yeah, you're going to need to do this. Find x, and then do 4 and x, so 4 squared and x squared whenever you find x, to find this part right here. And we're going to have to do this together because we have little bits and pieces that are missing. So what is this? Tangent? Tangent of 60 degrees is equal to x over 4. So x is equal to what? Tangent of 60 times 4. So I'm going to say 7. I'm going to go with 7. Okay? I'm going to say x is 7. So this whole thing from top of the triangle to the bottom of the triangle is 7. Now, this part is 6, so that means this length is 6. So that means this little piece is right here is 1. Because 1 and 6 is going to make the whole piece. This part is 1. So if that's 7 and this is 4, we have to find this length. So 7 squared plus 4 squared, it's going to be your y squared. So 49 plus 16. 49 plus 16, 65 equals y squared. Square second answer. Y is equal to 8.0. I'm going to say 8. Let's just go with 8. 8.06 is actually what it is, but I'm going to go with 8. So 8 plus 1 plus 7 plus 6 plus 11 should give you the whole perimeter of the thing. All right, I'm going to stop here on this one. I'm going to do 26 in the next problem because this one's already way too long already.